Then under dimensional analysis and modeling, we shall be considering dimensions and units, dimensional homogeneity, non-dimensionalization of equations. Sometimes it's very convenient to non-dimensionalize the equations. How it is done, why it is done, this will also be shown to you. It's so important to solve sometimes the real problem, and we see that it becomes easier to work with non-dimensional units. Dimensional analysis and homogeneity, dimensional analysis and similarity, then historical consideration by non-dimensional parameters, and whatever results we obtain, it's very important to verify them by carrying out experiments. So therefore, in most cases of the study of fluid mechanics, because this is applied to real life in various places in our life, therefore it has experimental value. No matter what results are expected by the solution of theoretical equations, mathematical equation, we need to verify them, how much they match with the real results, with the real fluid flow, of course, in a similar circumstances or in a similar environment which were assumed to solve those equations. So experimental testing, experimental verification is very important. So setting up of experimental experiment and then correlating the results that we get from our theoretical studies. Then in what is incomplete similarity. Lot of these tests, because if we are, for example, designing a car, designing an aeroplane to reduce drag and so on, then sometimes it is not very convenient that we drive a car with those specifications that we want to use, because the car has not been made. So to study a particular design and the specification that we want to introduce, the shape, experiments are carried out in tunnels, in areas what we call as wind tunnels. So because when a car comes on the road, what does it do? It is facing drag and it's moving against the wind. So a similar environment is created in a closed wind tunnel, and the wind is applied on the design, and then the drag measured or expected to be generated is calculated, and then an optimum design is reached. So a number of tests of various applications are made in what we call as wind tunnel. So wind tunnel testing plays an important role in designing number of applications. Flows with free surfaces, and then we also consider simply how a fly flies. It will be interesting just to see how a fly is flying. And if we study the flying of a fly, how does it help in making us, in designing different flying objects? Or does it help at all, or it doesn't, or does it? So we shall be studying that.